Welcome to today's webinar, an overview on the AWS platform. Presenting today is Sunil Maila. Today with us, we also have Victoria, Joel, and Guy serving as our webinar moderators. They will be engaging with you and answering your questions throughout the presentation while Sunil presents. Sunil, welcome. The floor is now yours.
Hi, I'm Sunil. I'm a solutions architect based out of San Francisco, working at AWS. I'm going to walk you through artificial intelligence and deep learning here at Amazon. So before I start, I'd like to give a little bit of an overview of what AI is. AI can be described as a branch of computer science and a set of algorithms that enable computers to do things that require human intelligence. So among these class of algorithms, there's a set of algorithms called deep learning, which has come to represent to solve problems that can absorb huge amounts of data. So they learn elegant patterns within the data to solve problems, for example, like detecting faces, meaning of a text, intent of a spoken word. Now, broadly speaking, deep learning are deep learning networks. So briefly, they have been inspired by how we think the human brain works, especially how the neurons collectively work together in our brains. Now, let's actually step back and look at the history of artificial intelligence within Amazon. So this is one of the earliest examples that you see from the late 90s here at Amazon, where we had a discovery agent that recommended books that you may like, for example, in your favorite genre or your author and so on. Now, since then, it's evolved. Amazon has applied artificial intelligence to solve a vast number of problems. We have thousands of employees focused on implementing solutions. And the result of that is you see we have products like Amazon Echo or Alexa, Amazon Go, the store in Seattle, where you can walk into a store without lines and just there's no checkout. Now, so the earliest, as I mentioned, was in the discovery and search within Amazon.com. But we have applied artificial intelligence and deep learning in our fulfillment and logistics centers. For example, we've had Kiva robots that have worked on they move things around within our fulfillment centers. We even have image recognition algorithms to help keep inventory within the fulfillment centers. There's a great reInvent talk 2016 on transforming industrial processes with deep learning. We will share the link to that as well. And in particular, for people who are interested, we do use convolution neural networks to use image recognition algorithms to keep the inventory. We use this to enhance products, and I think one of the most common and household name today is Alexa, where I see a lot of people here own the Echo device or an Alexa-enabled device. So we have, as I explained, a lot of different applications that we here at Amazon, but we wanted to democratize artificial intelligence, bring it to the masses, where we can have developers, researchers use machine learning and artificial intelligence and deep learning algorithms on AWS. So if we just step back and look at the advent of deep learning. So the algorithms themselves aren't new. It depends on who you ask. If you ask some of the AI researchers, they would say it's been around for 25 to 30 years. If you ask the mathematicians, they would say it's as old as 50 to 60 years. But what's made it more applicable to us is because of the following. We now live in a world where we've enabled to capture a lot of data. Now, thanks to the cloud and say services here at Amazon and AWS like Amazon S3, RDS, Snowmobile or Snowball to get your data into the cloud. Now, deep learning algorithms inherently are data hungry. They get better as you provide more data and samples for them to learn and train. Now, once you have this data, which has been made easier by the cloud, then we apply compute, and so these algorithms require a huge amount of compute and GPUs in particular, in case of deep learning. Now, the developers, data scientists, and machine learning researchers can get these compute easily on AWS and even GPUs that are tailored for these workloads with just a single click by spinning up the AMI or on EC2. Now, the final factor that kind of brings all this together is programming models. We've had a lot of easy frameworks that have made this easier, and various programming languages like we have support for these frameworks have support for Python, Scala, even Node.js. Now, where AWS is, it's here at the nucleus of all this. We provide the necessary tool set and services that help developers and researchers alike to get started with deep learning and productionize and solve problems. Now, we'll walk through some of the intelligence services that we have powered. So, Apache MXNet is the deep learning framework of choice at AWS and Amazon, and we've made this available through AMI, a deep learning AMI, and a lot of resources, tutorials, and notebooks. Amazon Poly. Poly is text to speech, and I will walk through each of these services. Rekognition, our image analysis service. And then Lex, which is our speech recognition service and natural language understanding, which allows you to build voice and text chatbots. Apache MXNet. Now, there are three basic advantages we see with MXNet. MXNet actually stands for Mixed Networks. Programmable, portable, and performant. We support various languages like Python, Scala, Node.js, R, Julia on MXNet. It's portable. What that means is you can actually train a network using GPUs, throw a lot of compute, but you can deploy that on just devices that have CPUs. Now, it could be a mobile device, it could be an IoT device, even a Raspberry Pi. Now, performance. We here like linear scaling. AWS has enabled a lot of scale for various customers. Now, we benchmarked various deep learning frameworks, and we found that as we provide more data, we could scale across hundreds of GPUs using MXNet. Now, we saw very linear, almost linear scaling with about 88% efficiency at 256 GPUs. Now, all these wonderful things actually helped us make the choice on MXNet as our framework of choice. It's also an Apache, it's got accepted into the Apache Incubator project, which makes it open source, and it is optimized on AWS, given we have the deep learning AMI, we have CloudFormation templates, which make it easier for our customers to use this at scale. MXNet, again, is a deep learning a framework of choice here at Amazon. We have instances that are tailored for GPU workloads. So the P2 family have up to 40K CUDA cores. We call it Deep AMI. We have AMI that is available at the marketplace, which come pre-populated with all the popular frameworks, deep learning frameworks for our customers. We also have a CloudFormation template that auto scales and provides easy setup for a deep learning cluster. Now, we have, as I mentioned earlier, we have the deep learning AMI that is available to set up with just a click of a button. It's available in Amazon Linux and Ubuntu, which we released just last week. We support all the popular frameworks, including Apache MXNet, Caffe, Theano, Torch, and TensorFlow. It also comes with pre-populated CUDA drivers, which make it really seamless for people to just start training or learning or even set it up for production. We have container images, Docker images, and the CloudFormation template as well. Amazon Polly. So Polly is our text-to-speech service. And this is, again, it is one of the components that you might find, that if you're familiar with Alexa, it's one of the components. So Polly is lifelike speech. It's a fully managed service which is available for developers where they don't need to understand the underlying algorithms, but they get to use it just like any other AWS service via an API. So you can send a text, you can get a speech output, which you can cache and use, and we impose no restriction on that. There are 47 different voices, including male and female, across 24 languages. It is low latency and scales and easy to use like most of AWS services. Now let's take it for a spin.
Alice was beginning to get very tired of sitting by her sister on the bank, and of having nothing to do. Once or twice she had peeped into the book her sister was reading, but it had no pictures or conversations in it. And what is the use of a book, thought Alice, without pictures or conversation?
Yes, so that was an example of how it sounds. Now, there are use cases where customers tell us, for example, it could be, context driven. You're talking about the weather, and you want it to be pronounced or certain acronyms to be actually spelled out. Let's actually.
Today in Seattle, Washington, it's 11 degrees Fahrenheit.
As you can see, it's smart enough to recognize the symbols and the context to actually spell it out as it speaks.
We live for the music live from the Madison Square Garden.
Now, that was an example where it's context driven. The word live or live is actually spelled the same way, but it actually understands the context and allows people to generate text that would just sound like how a human would actually pronounce and use it in the right context. Now, as I mentioned, we have applied deep learning techniques so that it is intelligible, but at the same time easy to understand.
How much would a woodchuck chuck if a woodchuck could chuck wood?
Now, I'm going to play that again. It's really hard for us as humans, at least most of us, to pronounce tongue twisters. Now, let's take that example.
How much would a woodchuck chuck if a woodchuck could chuck wood?
Now, there are examples where we might need to add semantic meaning to text. What that means is sometimes we might see numbers. Sometimes those numbers represent a phone number. So we provide XML, standardized XML, which is SSML, for people to annotate text and provide custom pronunciations or custom interpretations that are built in. Here's an example.
Richard's number is 2,122,341,237.
Now, clearly, we were looking at a phone number here. Now, if that is annotated, we could have it sound like
Richard's number is 212-234-1237.
Clearly, that was much better. And you can have customized pronunciations, again, depending upon geographic location and so on. We might pronounce certain names differently, and I think names are one of the best examples. And my colleague, who's in Poland, had, as he was presenting, one of the things while working the product was he wanted to pronounce his daughter's name appropriately. And depending upon, let's say you're in the US,
My daughter's name is Kaja.
that might be how you pronounce.
My daughter's name is Kaya.
Now, that would be the correct Polish pronunciation of the word and as desired by my colleague. So you can have and annotate for custom pronunciations so that whether those are names or words are represented accurately as you would like. So we have customers today using Poly, like Duolingo, which is a learning software, uses Poly. It's easy to use. It's built for production and low cost and scales. Let's move on to the next service, Rekognition. This is our image analysis service. Broadly, we have 4 different set of functionalities that is available today. Object and scene detection, face detection, face analysis, and face search. And all these APIs or these services can be used either in real time, or we have solutions and blogs that explain how we can use batch services, including AWS Batch, which is a batch processing service, or Lambda, to actually farm out and process a lot of images. So just to reiterate, you can do real-time predictions or you can do batch time predictions, whatever suits your needs. Here's an example of object and scene detection. So you could just give this image and it spits out a JSON that has categories and confidence levels. So what that means is there are labels it identifies in this example. Hey, this could be a bay or a beach or a coast and outdoors, but at the same time gives you a confidence level which you can use in your application. For example, you could filter out certain labels according to the taxonomy that you may choose. Facial detection. So any image that either you can upload the image through the API or you can point this in a S3 bucket location. And it'll give you various outputs, including emotion. We recently added age range. It tells you if the person's wearing a sunglass or an eyeglass or spectacles, eyes closed. It also gives you facial landmarks and a bounding box to tell you where the face is or in an image. And it can recognize multiple faces in a single image as well. Now, the other algorithms, we actually have, you can compare a couple of faces to do facial analysis and a differential, so to speak. You can search for faces in a collection. So what that means is you can create a collection, index, give it various number of images, and say an external ID to represent in your database, and then give it a novel image or a new image, and then it actually can give you back what is the closest looking image in that collection. So if you wanted an identity database, if you wanted to create, say, an employee database, you could do that. And then it would return the matching images. You can threshold this, but also you get a confidence level as well. And I'm going to show you a quick fun demo that I built out. So what I did was to show the example of facial indexes and collections. I took about 100,000 images from IMDb, the Internet Movie Database, and indexed that in a collection using Rekognition. And then what I will do here is select an image, one of my images, to see what my celebrity match would look like. And it has identified me to be from one of the familiar shows, Big Bang Theory, if you folks are familiar. So that was pretty fast. If you look at how it uploaded the image that I had and looked at the collection and found amongst those 100K images the best match. We have a lot of customers using Rekognition at scale. A couple of big examples are Redfin, the real estate app, and we have SmugMug, a photo sharing app, using Rekognition at scale. Again, Rekognition. There's a free tier as well for just like all our other services. Like Poly, for example, has a free tier. Rekognition does have a free tier where you get 5,000 images for the first 12 months. So I highly encourage you guys to play, and it'd be surprising to you. It just takes maybe 4 to 5 lines of code to actually get going with Rekognition. Next, moving on to Amazon Lex. So Lex is Lex is built on the engine that is at heart of Alexa. In fact, if you take the A's off Alexa, you do get Lex. So let's kind of let's step back and look at how our conversation, how interactions with a machine has evolved. So if you look at the very first interfaces, they were huge room-sized cabinet machines where it seemed like the humans had to do all the hard work. For example, you would punch cards or change wires, and the machine did not make any effort to make it easy or intuitive for you to use and interact with the machine. But then, as we evolved through the decades, it became simpler for us to use, where as the computers got cheaper and capable, there was more of interactions where, say, it was click-driven or swipe, or you would use a keyboard or mice or other pointing devices. So that evolved. But as with anything, we want to make it simpler and more accessible to people who might not be familiar to interact with machines. So in an era where the computing power is available as a utility at the end of an API, say the availability of power seems to kind of not be a constraint anymore. So what that means is now we can have intent-driven interfaces where even the computers can understand natural language, be it via text or speech. And this is what you see, for example, with Alexa or Echo. Now, all these is brought about and made easy and available through the Lex services. Now, you can build conversational interactions with text and voice. What that means again is you can build chatbots. Now, as I mentioned again, this is the underlying technology that powers Alexa. So you can build interactions on mobile, web, and any device that can be connected to the internet. Now we're looking to allow you to build these bots really easily and deploy across a multitude of platforms. Currently, you can deploy this to Facebook Messenger. You can do it to Slack. We have at our conference reInvent, we showed an example to deploy to on Twilio as well. But more importantly, it's got a REST interface to build and deploy chatbots. What that means is any device that can actually connect to the internet and has capability to call REST APIs can be Lex enabled. Now we've made a lot of enterprise connectors made available to make it easy for our customers to build enterprise applications. For example, employees can check sales data, say from Salesforce. All you need to do is configure a Lambda function in the background and connect to Salesforce. So now your sales organization needn't run or write complex reports. You can just have it at via a text interface or voice in the browser. Marketing performance. HubSpot is one of the customers leveraging Lex. So they get a lot of performance, customer service status from Zendesk. So with Lex, customers can build bots to connect to a variety of enterprise productivity through tools, as I mentioned again, made possible through Lambda functions. I will show you a quick demo of Lex. Now, Lex currently is a service that is available in preview. You can go register, explain your use case, and we will work and get you whitelisted as soon as possible. So just like any interface, you can start by just greeting, and here you see the chatbot, talking to us. Hey, welcome to movie. This is a movie PDF where I'm just trying to talk and query on a certain movie that I may like and find more information on that. Confirm the movie name that we want. I'd like to know something about Jaws, and it asks, I wonder who the it's asking me, hey, what is the information, years, actors, plot. I want to know who the director, I kind of forget. I think it's Steven Spielberg. Let's see. Yes, so as you can see, there can be friction sometimes with talking to a bot. So you can actually configure cases where it actually, if it doesn't understand, you can it'll actually get back to you on, you can have sorry messages or error handling as well. So you can have a nice way of either ending conversations or actually getting the bot to respond as you need. So again, as I mentioned, Lexus is currently in preview, and you can get whitelisted on the AWS website. So essentially what happens is Lex does the heavy lifting of the natural language understanding. And then it queries back to your Lambda function, which is where your bot logic lives. Now, in your bot logic, you can, which is again in a Lambda function, you can code it within your Lambda function, or you can make external API calls. In this case, making external calls into a third-party API to get the information, which again is returned by the Lambda function. Now, we just to summarize, so we went through Amazon Poly, which is our text-to-speech service, Rekognition, the image analysis service, and Lex to build chatbots. Now, MXNet, just to reiterate, so this is available. It's an open source project, made easy. This is our deep learning framework of choice. We have a lot of customers using, for example, TuSimple is using this to train their models to enable self-driving autonomous cars. We have Mapillary, who's using this to, using computer vision algorithms trained on the deep learning framework here to actually infer from crowdsourced maps to create intelligent navigatable maps. So AI in general, as I said, is very important, has been applied and being worked on Amazon for a long time. Now, if you look at the AWS proven pace of innovation in each of the service, you can expect the same in each of these services. And we will roll out new features over time. Now, we're making big investments in MXNet. We're making resources like notebooks, a lot of documentation and tools and APIs available for all of the services. Now, more importantly, we're making it easy for people to get started on AI, whether you're a researcher or a developer. We are democratizing artificial intelligence through AI-enabled services and also making it simpler for people to get started with deep learning frameworks with Apache MXNet. So I would encourage people to go check out our Amazon AI page, aws.amazon.com/amazon-AI. It's a great gateway into starting on AI and also all these services that I talked about. Now, just as a reminder, we will have regular cadence on Mondays on various different topics within the AI umbrella. So please stay tuned for that.